And welcome back. As we kind of do a quick wrap up on our concepts of derived classes, we need to talk about one little thing yet, which is the this constructor. Now, we've already talked a little bit about how to call constructors. We looked at how we use the super invocator, but a little bit of a recap. When we're defining a constructor, it's sometimes convenient to be able to call one of the other constructors within the same class, because sometimes we have multiple different things, whether it's a no-R constructor, a parameterized constructor, etc. If we want to help differentiate things, we can use the keyword this as a method name to invoke a constructor within that same class. Now, the use of this is very similar to how we use the keyword super, but with this, the call is to a constructor of the same class, not to a constructor of the base class. So it's going to function pretty similar, except again, we're not using the super call, we're using the this call. Now, with the this constructor, let's just look at this with an example. Consider if we had this alternate definition for our no-R constructor of hourly employee. Public hourly employee, this, no name, comma, new date, quote, January, comma 1, comma 1000, comma 00. All right. If you think about this, this is replacing that super call where we would have to pass in like the name, the date, things like that, that would exist within inside of that employee. And so instead of this, effectively using that base class, it is now passing these values as that default. And of course, this is our values here for hourly employee. Now, the line with this is an invocation of the constructor with the following headline. So this is effectively the same thing as public hourly employee string, the name, the date, double wage rate, double the hours. You've noticed, again, these are very similar, except this is making it so it's a single invocation here rather than using it through the parameters. Now, there are some restrictions on using this because you might say this could be pretty handy, and it can be, but there, of course, are restrictions. Now, the restrictions on how we use the base class constructor call super apply here to this as well. For example, you cannot use an instant variable as an argument to this. And any call to the constructor this must always be the first action taken within a constructor definition. And you might already see that we have a potential conflict coming into play here. A constructor definition cannot contain both the invocation of super and invocation of this, because remember, they both need to be at the top of that method definition. If we wanted to include both a call to super and a call to this, instead use a call with this. All right, that would be the thing. If you want to have both those, use the this call and have that constructor therefore call with the keyword this, what you would have super use as its first action. So you have to do a little bit of work there to kind of make that work the way you want to. I personally, just like when I talk about this, we looked at the instance variables and parameters and local variables and stuff like that in method constructions, I tend to avoid using this personally, simply because it's easier for me as a programmer to kind of keep things straight. But again, this can be useful if you want to use it. Now, here's a quick tip for you. That an object of a derived class technically can have more than one type. And you might say, well, how could that be? Well, let's just look at this. An object of a derived class has the type of the derived class, and that makes sense. If we have an employee object, we create a derived class called hourly employee. Well, the hourly employee is going to be an hourly employee. But it also has the type of the base class, and more generally has the type of every one of its ancestor classes. So, that hourly employee is technically also an employee. Now, if we look at the copy constructor definition from hourly employee, all right, we have hourly employee, our employee original object, super original object, blah, blah, blah. You'll notice we are passing, of course, in the hourly employee as the object here. And that kind of gives us to asking, well, what about these derived class types? Well, with the derived class types, that line super original object is actually an invocation of a constructor for the base class employee. It's actually not an hourly employee, it's actually an employee one, because again, we're looking back at the base class construction. The class employee, if you notice, has no instructor with the parameter of type hourly employee. It would make sense because, again, it's the base class. But original object is of type hourly employee. Now, fortunately for us, every type of hourly employee is also a type of employee. It's actually, this is an invocation of super, which is an invocation of a copy constructor for the class employee. And that leads us into this idea of this is a relationship. And the fact that every object not only has its own type, but is also a type of its ancestor class simply affects things in the real world. So if we were to look at the real world, and let's say I have a business where I have hourly employees. Well, even though they're hourly employees, they're still technically also my employees, as well as being specifically just an hourly employee rather than a salaried employee. This is what is referred to as that is a relationship. For example, an hourly employee is an employee. So is a employee. Now, we're going to look here in a minute the updated employee record class, which is to demonstrate that is a relationship between the hourly employee and salaried employees and how they relate back to the hourly or just the regular employee objects, The method show employee requires an argument of type employee. The objects Alex and Sam are of type employee because they're instances of classes derived from that class employee, and so therefore are suitable arguments for the method show employee. So in here, of course, I have my employee record class. I updated it with some new code here, and of course, you'll see this in the materials. You'll see we, of course, have our original code here where we just went and updated that record, which is great. But now we added this salaried employee information in here. And, of course, we are constructing our salaried employees. This is pretty much what we expect. And, of course, we have a getName method. We are saying, hey, we want to show that it has been invoked. And you notice we have this show employee here now. Show employee, of course, is this little method I have right here. And if you look, what is it passing? It's not passing a salaried employee. It's passing an employee object, which is very important because, again, if you look at Alex and Sam, both of these are different types of objects. Alex is a salaried employee. Sam is an hourly employee. However, both of these are employee objects, which means if I pass these in here, it should not cause issues because if you notice, it's only getting a name and a hire date, which of course are things that only exist within employee. If I were trying to, let's say, get something that only belonged to salaried employee, then I could run into issues because obviously this wouldn't work because Sam would not be a salaried employee. And if I run my code, you will see we get exactly what we kind of expect. If we call the show employee for Alex here, you'll see it gets the name, it gets the hire date. And if we look at Sam, it gets a name and gets the hire date. Again, because these two objects exist as employee objects in addition to being just a salaried employee or an hourly employee. Now, one last thing to close out on, which is a quick pitfall for you, which is the terms subclass and superclass. We've talked a little bit about these already, but I wanted to remind you about them. And the reason why is that because many programs will sometimes use the term subclass for a derived class and superclass for a base class or any other class. For example, the collection of all objects of type hourly employee is a subcollection of the collection of all objects of class employee. All right, it's what we kind of expect, right? Derived class and base class. Now, as you add more instance variables and methods, remember you're restricting the number of objects that can technically satisfy the class definition. If we look at hourly employee, it has new parameters that exist that did not exist inside of an employee object. And remember that these terms refer, therefore, to the collections of the derived classes and the base class, and not to the number of instance variables and methods. All right, you're not going to all of a sudden say sub and super because one thing or another. Oh, I have more instance variables, therefore I must be a super class. Well, it doesn't necessarily refer to it that way because remember, you can split off derived classes into multiple different branches, making a bunch of crazy different things. If we look back at that very first flowchart that we did when we looked at the salaried employee branch, there was probably like 5 or 6 different branches that we could do in that sample diagram, whereas the hourly employee had like full-time and part-time, and that was it. So simply looking at the number of instance variables is not necessarily a key indicator of whether something is a superclass or subclass, but instead you want to look at how those objects are collected.